Welcome to this section where we will look at the different storage options for EC2 instances. So first, the most important ones are going to be EBS volumes, so let's define what they are. An EBS volume stands for Elastic Block Store. It's a network drive that you can attach to your instances while they run, and we've been using them without even knowing. So this EBS volumes allow us to persist data even after the instance is terminated. And so that's the whole purpose. We can recreate an instance and mount the same EBS volume from before, and we will get back our data. That is very helpful. So these EBS volumes at the CCP level can only be mounted to one instance at a time, okay? And when you create an EBS volume, it is bound to a specific availability zone. That means that you cannot have an EBS volume created in, for example, in US East 1A attached to an instance in US East 1B. We'll see this in the diagram in a second. So how do you think of EBS volumes? Well, you can think of them as network USB sticks. So it's a USB stick that you can take from a computer and put it in another computer, but you actually don't physically put it in a computer. It's attached through the network. The free tier gives us 30 gigabytes of free EBS storage of type general purpose, so SSD, or magnetic per month, and in this course we'll be using this with the GP2 or GP3 volumes. Now let's look at it. So EBS volumes are network drive, as I said, it's not a physical drive, okay? So to communicate between the instance and the EBS volume, it will be using the network. And because the network is used, there may be a bit of latency from one computer to reach to another server. Now, EBS volumes, because they are a network drive, they can be detached from an EC2 instance and attached to another one very quickly. And that makes it super handy when you want to do failovers, for example. EBS volumes are locked to a specific availability zones. That means that, as I said, if it's created in US East 1A, it cannot be attached to US East 1B, but we will see in this section that if we do a snapshot, then we are able to move a volume across from different availability zones. And finally, it's a volume, so you have to provision capacity in advance. So you need to say how many gigabytes you want in advance, and the IOPS, which is I/O operations per second, and you're basically defining how you want your EBS volume to perform. You're going to get billed for that provisioned capacity, and you can increase the capacity over time if you want to have better performance or more size. So, as a diagram, what does it look like? Well, we have US East 1A, we have one EC2 instance, and we can attach, for example, one EBS volume to that EC2 instance. If we create another EC2 instance, as I said, an EBS volume cannot be attached to two instances at a time at the Certified Cloud Practitioner level. And therefore, what I want to say is that this other EC2 instance needs to have its own EBS volume attached to it, but it is very possible for us to have two EBS volumes attached to one instance. Think of it as two network USB sticks into one machine. That makes a lot of sense. Now, EBS volumes are linked to an availability zone. So as we can see, all this diagram has been so far using US East 1A. So if you wanted to have other EBS volumes in another AZ, then you would need to create this separately in the other availability zone. So just same way that your EC2 instances are bound to an AZ, so are the EBS volumes. Finally, it is possible for us to create EBS volumes and leave them unattached. They don't need to be necessarily attached to an EC2 instance. They can be attached on demand, and that makes it very, very powerful. Finally, when we go ahead and create EBS volumes through EC2 instances, there is this thing called a delete on termination attribute, and this can come up in the exam. So if we look at this, when we create an EBS volume in the console, when we create an EC2 instance, there is the second to last column called delete on termination. And by default, it is ticked for the root volume and not ticked for a new EBS volume. So this controls the EBS behavior when an EC2 instance is being terminated. So by default, as we can see, the root EBS volume is deleted alongside the instance being terminated. So it's enabled. And by default, any other attached EBS volume is not deleted because it's disabled by default. But obviously, as we can see in this UI, we can control if you want to enable or disable delete on termination. And so a use case for it would be, for example, that if you want to preserve the root volume when an instance is terminated, for example, to save some data, then you can disable delete on termination for the root volume and you'll be good to go. And that could be an exam scenario at the exam. So I hope you liked it, and I will see you in the next lecture. So let's have a look at the EBS volumes attached to our instance. So if you click on instance and then you go to the storage tab in here, you find that there is a root device and there's a block device on it. As you can see, we get one volume of 8 GB currently attached into our EC2 instance. So what I can do is I can click on this volume and it will take me into the volumes interface of AWS. And we can see that yes, indeed, our volume exists and it's there. It's in use as shown here, and it's attached to an instance right here. So we have a different kind of console here. And to access it, you can just go on the left-hand side and click on volumes. So as we can see now, we have one EBS of 8 GB. And what I can do is I can create a second volume. So let me create a volume. And I will have many options to choose from, GP2, GP3, and so on, but I will just use GP2 of type of size 2 GB. And then for availability zone, I need to choose the same one where my EC2 instance is. So for this, I'm going to go into my EC2 instance in here, and I will find which availability zone it is on. So I scroll down, and it is going to be in the networking one. So I scroll down in the networking, and here, availability zone, it says EU West 1B. Therefore, the volume I will create is going to be in EU West 1B because the EBS volumes are bound by a specific AZ. So that's good. I will have it done and create this volume. And now my volume is created. And what I can do is if I can click on it, this one is currently not attached. Okay, so it's being creating. So let me refresh this to see if it's created. Okay, it's available and it's not attached yet. So therefore, because it's available, what I can do is action, and then I can attach the volume, and we need to find an instance. So we have one running right here. And so we're going to attach this volume to my instance, click on attach volume, and voila, our instance now has two EBS volumes attached to it. How do we know? Well, I can refresh this page, go to storage on my EC2 console, scroll down. As you can see now for block devices, I have two block devices. I have the one of 8 GB and the one of 2 GB. To actually use this new block device, it's a bit more complicated and out of scope for this course, but you can go to Format, EBS, Volume, Attach, EC2, and you should find something like, yes, make an Amazon EBS volume available to use on Linux, and this gives you instructions on how to do it, but again, this is out of scope for this. So now if I go into my volumes and I create a volume, I can create a volume of 2 GB of GP2, but this time the AZ is going to be EU West 1A and not EU West 1B. So it's going to be a different AZ than the one of my EC2 instance. And the reason I do so is to show you that right now we have 3 GP2 volumes. So let me refresh this. So the last one is available and it's a different AZ, so EU West 1A. And if I do actions and then attach volume, as you can see, I cannot attach it to my EC2 instance because my EC2 instance is in EU West 1B. And so therefore, we can see that the EBS values indeed are bound by a specific availability zone. Lastly, what I can do is that I can take this volume, do action, delete volume, and it's gone. And that really shows you the power of the cloud. I can just request volumes, delete volumes right on the go in the matters of seconds. Okay, so we have our two EBS volumes in here. And what I want to show you now is a cool behavior. So what happens if I terminate my instance? Well, remember, and I will show you again, this one root volume of 8 GB has the delete on termination attribute. So how do we know? Well, if I go into my storage and then go to my block devices into this table right here and scroll all the way right, you see the first one has delete on termination yes, and the second one no. So why this one is yes? Well, I don't know if you remember, but when you go through the process of launching an instance, okay, and then you scroll down to the storage, in here, if you click on advanced, you can see the fact that it is your root of 8 GB, and by default, this delete on termination attribute is yes, which makes sense, but you could set it to no if you wanted to keep the root after terminating your instance. But so this explains why we see from before the yes in this table. And so therefore, if I go ahead and terminate my instance, which I will, so it says successfully terminated, so it's going to really remove it from here. I can go back into my EBS volumes. I can refresh them. And what's going to happen is that this one soon is going to be available. So because it's going to be detached from my EC2 instance, and then it's going to be terminated. So I'm going to pause until this is done. And here we go. So my 8 GB volume has now disappeared. Only my 2 GB volume is left. And if I go to my EC2 console, well, it says that my first instance has been terminated. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about EBS snapshots. So you can take your EBS volumes and make a snapshot, which is also called a backup, at any point of time that you wanted to. The idea is that you will be able to back up the state of it, and even if the EBS volume is terminated later on, you could restore it from that backup. Now, to make a backup, it is not necessary to detach the volume prior to doing the backup, but it is recommended just to make sure that everything is clean on your EBS volume. And why do we do snapshots? Well, we can obviously restore them, but we can also copy snapshots across availability zones or regions. And the idea is that you would be able to transfer some of your data in a different region on AWS to leverage the global infrastructure. So if we look at ES East 1A and we want to transfer an EBS volume to ES East 1B, the way we would do it is that we would have the EBS volume attached to the EC2 instance, and then we would snapshot it. So maybe we would stop the EC2 instance ahead of time to make sure the snapshot is clean, or we could just do it on the fly. It is really up to you and based on how you have programmed your EC2 instance. Now the EBS snapshots exist in your region, and that EBS snapshot can be used to restore a new EBS volume in another availability zone. And then now that this is done, we can attach the new EBS volume to an EC2 instance in ES East 1B. And there we go. We have successfully and effectively transferred an EBS volume through a snapshot across AZ. So some features you need to know about for EBS snapshots is the first one, an EBS snapshot archive. So it allows you to move your snapshots to another storage tier called an archive tier. And that tier is 75% cheaper. So your snapshot is going to be moved, manually or whatever, however you set to the archive tier. But if you have it in your archive, it takes you between 24 to 72 hours to restore from the archive. So these are for snapshots that are not very important to you to restore in a rush, okay? But you want to save some cost on them. The second feature is around recycle bin for EBS snapshots. So by default, when you delete snapshots, they're gone, but you can set up a recycle bin, and the recycle bin will have all the snapshots that are deleted. And then after a while, maybe you can specify from 1 day to 1 year, the snapshots are gone from the bin. So on deleting a snapshot, it would go into a recycle bin, and you may have, for example, 1 year to recover the snapshot, which allows you to protect yourself against accidental deletion. Okay, that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So we have this 2 GB GP2 EBS volume available to us, and we can take a snapshot from it. So if we do actions, we can create a snapshot. So we can add a description, for example, demo snapshots, and then click on create snapshots. So then on the left-hand side menu, instead of volumes, you can click on snapshots. And snapshots show you the list of all the snapshots you have. And as you can see, we have one right here. It is completed. It is 100% available. And we get some information around that snapshot itself. First of all, what we can do is that we can copy this snapshot into other region. So if you right click and do copy snapshots, then as you can see, you can copy the snapshot into any destination region that you want. And this can come in very handy in case you want, for example, to have a disaster recovery strategy to make sure your data is backed up in another region of AWS. So I won't do so, but you get the idea. Another thing I can do is take the snapshot and I can recreate a volume from it. So action, create volume from snapshots. And we choose a 2 GB GP2 volume. And then the target AZ doesn't have to remain EU West 1A. It can be, for example, EU West 1B. And we can also encrypt this volume if we wanted to and add some tags. And so as we can see, when we click on create volume, what's going to happen is that if we go back into our volumes, well, now we have 2 volumes, as you can see, and one of them, this one, was restored through a snapshot, okay? And it is an EU West 1B. So the idea is that thanks to snapshots, we can, quote unquote, copy EBS volumes across different availability zones. And that's very handy. If we look again at snapshots, we can have a look at what's called the recycle bin. So the recycle bin is a way for you to protect your EBS snapshots from accidental deletion as well as your Amazon machine images. So we can create a retention rule and saying demo retention rule. And then we're saying we'll apply this to all EBS snapshots, and I want them to be retained for 1 day after deletion, which allows me to recover them. So if I click on create retention rule, now it has been created and it is going to appear right here at some point. Okay, so let's refresh the page for us to see it. Here it is. And now on the resources, we can see if we have resources in the recycle bin. So let's go back into our snapshots in the EC2 console. So I'm going to go into EC2. Here we go, snapshots, little shortcuts. And what I'm going to do is take the snapshots. And first, before I delete it, I want to show you the storage tier. So right now it is a standard storage tier, okay? But you can move the storage tier by archiving a snapshot, and this will allow you to move the storage tier into another pricing level. But if you want to restore it, of course, you will have to wait 24 to 72 hours. So just to show you, but anyway, let's go ahead and delete the snapshot. So we'll delete the snapshots. As you can see, it's gone. And before, it used to completely delete the snapshots and you couldn't recover it, okay? As you can see, it's gone. But now, thanks to the recycle bin, well, if I refresh here, my resources, I can now see that my snapshot has appeared here. And what I can do is click on it and recover it. Yes, recover resources. And voila, it's back into my snapshots on my EC2 console. Okay, that was pretty awesome, right? Okay, that's it for EBS snapshots. I hope you liked it, and I will see you in the next lecture. Now let's talk about what powers our EC2 instances, which is an AMI. So AMI stands for Amazon Machine Image, and they represent a customization of an EC2 instance. So you can use AMIs created by AWS, or you can customize it into your own. And what is in an AMI? Well, we have our own software configuration. We can define and set up the operating system. We can set up any monitoring tool. And if we create our own AMI, we're going to get a faster boot time and configuration time because all the software that we want to install onto our EC2 instance is going to be prepackaged through the AMI. So we have to build our own AMIs, and they can be built for a specific region, and then they can be copied across region if we wanted to use it and leverage the AWS global infrastructure. So we can launch EC2 instances from different kind of AMIs. What we've been doing so far in this course is to use a public AMI, and these are provided by AWS. So the Amazon Linux 2 AMI is a very popular AMI for AWS, and it was provided by AWS themselves. But we can create our own AMI, then therefore you have to make and maintain them yourself. There are tools obviously to automate this, but this is a task that you have to do as a cloud user. Or finally, you can launch an EC2 instance from an AWS Marketplace AMI, which is an AMI that has been made by someone else and potentially sold by someone else. So it is quite common to have vendors on AWS to create their own AMIs with their own software, with a nice configuration and so on. And then they will sell it through the marketplace AMI for you to buy it and to save some time. And even you, as a user, you could create a business of selling AMIs on the AWS marketplace. This is something that some businesses do. Okay, so the AMI process from an EC2 instance, how does it work? Well, we'll start an EC2 instance and we'll customize it. Then we will stop the instance to make sure the data integrity is correct. Then we can build an AMI from it. So this will also create EBS snapshots behind the scenes. And then finally, we can launch instances from other AMIs. So this is what we'll be doing in the demo in the next lecture. So we have US East 1A, and we can create the same instance as US East 1B. So the process is we launch the instance in US East 1A. We're going to customize it. Then we're going to create an AMI from it. This will be our custom AMI. And then in US East 1B, we will be able to launch from that AMI and will effectively create a copy of our EC2 instance. So I hope you're excited, and I will see you in the next lecture. So let's go ahead and practice using AMIs. For this, I'm going to launch an instance, and I'm going to go into this new experience. So I will scroll down, we'll choose Amazon Linux 2. I will scroll down again. We'll use the T2 micro. I will select the EC2 tutorial as my key pair, but it doesn't really matter. Then I will scroll down. I would edit the network settings, and I will select an existing security group, being my launch wizard 1 from before. Then we'll have the same storage, and for advanced details, I will scroll down, and I'll go for user data. But this time, you're going to copy everything but the last line. So in the first 4 lines, we actually install HTTPD, which is the Apache web server. And then the last line, we create an index file. But right now, we don't want to create an index file. We want to do everything but that to create an AMI out of it. So we just copy everything. Remember, the last line is the systemctl command. And then we launch our instance. So our instance is launched, and what's going to happen is that the instance is going to launch, so it's right here, and then it's going to run through the EC2 user data script, and it's going to install the Apache web server. So if I'm too quick and I try to open right now this public IPv4 and try to enter into it, as you can see, it doesn't work. I'll get a connection error, refused, and so on. I need to make sure I'm also using the HTTP protocol, of course. But it just won't work, right? Because you need to give it a bit of time, even if it says running, you need to give it time for the EC2 user data script to run for the first time. So this might take a minute, this might take 2 minutes, okay? But don't be in a rush, just wait for it to be done. And then at some point when you refresh, you will see the screen. So let me pause the video. And it took about 2 minutes, but now I have my test page, and this is the basic page from the Apache web server. And therefore we are good to go. So what we're going to do out of it is we're going to create an AMI because we want to just save the state of our EC2 instance and reuse that. So I right click and I will do image and template, and then I will create an image. So we'll call this one demo image, and we're going to create our own AMI. And then we have these settings right here. We'll just leave it as is. Go here and click on create image. So now what's going to happen is that an AMI is going to be created. So if I go to the left-hand side and click on AMIs, as we can see here, my demo AMI is registered. And right now the status is pending because it is being created. So what I need to do is to be a little bit patient and for it to go into the created state. So my Amazon AMI is now created. And what I can do now is I can launch instances from this AMI by clicking here. Or if you are in the instance creation page, we can launch instances. And this one is called from AMI. And in here, in the quick start, we get access to the ones we know, but you can also go into the My AMIs tab, okay? And you have the ones owned by me, and you can choose the demo image that you just created from before. So in that case, you scroll down, you select a key pair or not, just up to you. Network settings, again, we edit them, and we just select the existing launch wizard 1 security group. And what I'm going to do is that in the advanced, at the very bottom, I'm going to enter some user data. So I copy the first 3 lines, okay, which are starting with a hash, and then the last line, which is the echo on the new line. And so what we do is that we only just write a new file. So we don't need to reinstall HTTPD because this AMI already contains HTTPD, which is why we will speed up in the boot up time. This is why you would create an AMI. So we launch an instance, and now the instance is launched. So I can just click on it. This is the one from the AMI. I need to wait for it to be fully created. My instance from my AMI is now running. I take the public IP address, and then I see the hello world from this. And as you can see, this was much quicker because we didn't have to install HTTPD again. So this is the whole power of AMIs. And you can imagine, well, it could be just more than that. It could be security software, a lot of prerequisite software, and so on. You install it, maybe it takes 2-3 minutes to do it. Then you package it as an AMI, and then you just start from the AMI, maybe do some end customization at the end, but you have a much faster boot up and you're good to go. So that's it for this demo. Now to get back from this, what you do is that you take your 2 instances and you can terminate them. And that's it. I will see you in the next lecture. Okay, so let's talk about a new service that I really like and that does come up in the exam now. It is called EC2 Image Builder. It is used to automate the creation of virtual machines or container images. Concretely, what does that mean for the exam? That means that you're going to be able, with EC2 Image Builder, to automate the creation, maintain, validate, and test AMIs for EC2 instances. So let's have a look at a diagram to see how that works in a detail. So we have the EC2 Image Builder service, and we're going to set it up, as we'll see in the next lecture. And it is automatically when it's going to run, it is going to create an EC2 instance called a builder EC2 instance. And that EC2 instance is going to build components and customize the software. For example, install Java, update the CLI, update the software system, maybe install firewalls, whatever you define to happen on that EC2 instance, maybe install your application. And then once this is done, then an AMI is going to be created out of that EC2 instance. But all of this is obviously automated. Then the AMI is created, but we want to validate it. So EC2 Image Builder will automatically create a test EC2 instance from that AMI and going to run a bunch of tests that you are defining in advance. And if you don't want to run any tests, obviously you can just skip that test. But the test can be asking, is the AMI working? Is it secure? Is my application running correctly? All these kind of things. And then once the AMI is tested, then the AMI is going to be distributed. So while EC2 Image Builder is a regional service, it is possible for you to take that AMI and distribute it to multiple regions, therefore allowing your application and your workflow to be truly global. Next, EC2 Image Builder can be run on a schedule. So you can define a weekly schedule, or you can say you can run whenever packages are updated, or you can run it manually, etc., etc. And it is a free service, so you're only going to pay for the underlying resources. What does that mean? Well, that means that if you create an EC2 instance during this process, and EC2 Image Builder will create these EC2 instances, then you're going to pay for these EC2 instances. And when the AMI is created and distributed, you're going to pay for the storage of that AMI wherever it has been created and wherever it has been distributed. But that should make sense, right? So I will see you in the next lecture. So we've seen a way to attach a network drive onto our EC2 instances, but they have limited performance, and I say with quotes because it's actually really good performance, but sometimes you want something even higher performance, and that is going to be a hardware disk attached onto your EC2 instance. So the EC2 instance is a virtual machine, but it is obviously attached to a real hardware server, and some of these servers do have disk space that is attached directly, with a physical connection onto the server. And so a special type of EC2 instance can leverage something called an EC2 instance store, which is the name of the hardware, the hard drive attached to the physical server. So what we use EC2 instance store, we will use them for better IO performance. We will also make sure that they have good throughput and so on. So they're a great choice when you want to have extremely high disk performance. But the caveat is that if you stop or you terminate your EC2 instance that has an instance store, then the storage will be lost. And therefore, it's called an ephemeral storage. So that means that the EC2 instance store cannot be used as a durable, long-term place to store your data. So what is a good use case for it then? Well, if you have a buffer, a cache, you want to have scratch data or temporary content, this would be a great place to do these things, but not for long-term storage. For long-term storage, EBS, for example, is a great use case. Finally, in case the underlying server of the EC2 instance does fail, then you'll risk to have a data loss because the hardware attached to the EC2 instance will fail as well. So if you do decide to use an EC2 instance store, then it is your entire responsibility to make sure that you back it up and that you replicate it correctly based on your needs. So what I mean by better performance, this is just an example to illustrate it, don't need to know it, but if we look at, for example, the instance size of i3 something, there is an instance store attached to these kind of instances, and if you look at the read IOPS and the write IOPS, which correspond to how many IO operations we can do per second, then you can see that some of these random read IOPS and write IOPS can reach 3.3 million or 1.4 million for the most performant one. And to put this in comparison, with an EBS volume of type GP2, for example, you can reach 32,000 IOPS So this is a lot more. But again, it's just to illustrate my point. From an exam perspective, anytime you see very high performance hardware attached volume for your EC2 instances, think local EC2 instance store. That's it. I will see you in the next lecture. Now here's a third type of storage you can attach onto an EC2 instance, and this is a network file system, or NFS. So EFS stands for Elastic File System, and it is a managed network file system, and the idea and the benefit of it is that it can be mounted to hundreds of EC2 instances at a time. So before we had an EBS volume attached to only one EC2 instance at a time, but with an EFS drive, you can mount it onto hundreds of EC2 instances. So that makes it a shared network file system, or shared NFS. So EFS works only with your Linux EC2 instances, and on top of it, it works across multiple availability zones. So it is possible for an instance in one AZ to be attaching the same EFS volume as the instance in another AZ. Now, EFS is highly available, scalable, pretty expensive. It's about 3 times the price of a GP2 EBS volume, but you pay per use and you don't plan for capacity. So that means that if you store 20 gigabytes of data onto your EFS drive, then you're only going to pay for these 20 gigabytes. So if you look at the diagram, this is very easy. We have an EFS file system with a security group. And then we have EC2 instances in various availability zones connected to it. So we have EC2 instances in US East 1A, EC2 instances in US East 1B, as well as EC2 instances in US East 1C, and they're all connected to the same EFS file system. So now let's outline the exact differences between EBS and EFS. So with EBS, say we had an EC2 instance in one AZ and another one, then the EBS volume can only be attached to one instance in one specific AZ, and the EBS volumes are bound to a specific availability zones. But if we wanted to move over the EBS volume from one AZ to another, we could create a snapshot, and we create an EBS snapshot, and then restore that snapshot into a new availability zone, and effectively we would have moved the EBS volume over. But this is a copy, okay? This is not an in-sync replica, this is a copy, and that would mean that this drive can now be used by another EC2 instance. EFS is a network file system. That means that whatever is on the EFS drive is shared by everything that is mounted to it. So what does that mean? Say we have many instances in availability zone 1, or many instances as well on availability zone 2. At the same time, all these instances can mount the same EFS drive, okay, using a mount target, and they will all see the same files. So that makes it a shared file system. So hopefully that makes it a very easy way to understand the difference between EBS and EFS, and this is something that the exam will test you on. There is a storage class you need to know for EFS, and it's called EFS Infrequent Access, or EFS IA. So it's a storage class that is going to be cost optimized for files that you don't access very often. So for example, you don't access these files every day. And this storage class will give you up to 92% lower cost for storing the data compared to the other storage class, which is called EFS Standard. And if you enable EFS IA, then EFS will automatically move your files to EFS IA based on the last times they were accessed and something called a lifecycle policy. So let's take an example. We have our EFS file system. We have 3 files in EFS Standard and maybe a 4th file in EFS Standard. This one hasn't been accessed for 60 days. That means that no one has read this file and no one has been writing to this file either, right? So if you define your lifecycle policy and you enable EFS IA, then for example, you can say, hey, after 60 days, please move this file to a different storage class, which is called EFS IA, which is going to have some cost saving. And this is going to be done automatically. Now, next time you access this file, it's going to be put back into EFS Standard because it's more accessed more often, right? So the idea is that this is a cost-saving optimization. And from an application perspective, there is really no drawbacks. It's very transparent to the applications. I mean that your applications don't even need to know where the file is. If it's an EFS Standard or EFS IA, it will access all these files the same way. It's just behind the scenes, EFS will do some cost optimizations. So something to need to know going to the exam. I hope you liked it, and I will see you in the next lecture. As usual, shared responsibility is important going into the Certified Cloud Practitioner exam, and so we need to understand where is the responsibility for AWS and yours regarding EC2 storage. So AWS, of course, is responsible for their infrastructure, but also because in the technical specification of EBS and EFS, They tell you the data is replicated across many hardware. It is AWS responsibility to perform that replication so that if one day some hardware is not working, you as a customer is not impacted. Also, any times an EBS drive would fail or one part of it would fail, it is obviously AWS responsibility to replace that faulty hardware. And finally, because we're talking about data storage, it is their responsibility to ensuring that their employees cannot access your data. Now, what is your responsibility as a customer? Well, setting up any backup or snapshot procedures and guidelines is very important to ensure that you don't lose your data. Setting up data encryption is another layer of protection to ensure that people cannot have access to your data, would it be AWS or other customers of AWS, even though obviously security would be in place for it not to happen, but it would be an interesting second layer of security. Any data you set obviously on the drive is your responsibility. Anything you write to that disk is your own responsibility. And if you're using an EC2 instance store, you need to understand the risks that are associated with it, which is that you can lose the drive if somehow there's a faulty hardware, or that if you stop or terminate the EC2 instance that has an instance store, then the data will be lost. So again, it would be your responsibility to back it up in the first place. Okay, that's it. I hope that was helpful, and I will see you in the next lecture. Okay, so now let's talk about Amazon FSx, which is a managed service to get third-party high-performance file systems on AWS. So in case you don't want to use EFS or S3 and you want something else, then you can use FSx to manage these file systems. So you have three offerings today. You have FSx for Lustre, FSx for Windows File Server, and FSx for NetApp ONTAP. And they can add file systems over time to the FSx service, I'm pretty sure, but I will not update this video unless you need to know about the other ones. So the two most important ones are going to be FSx for Lustre and FSx for Windows File Server, and this is what is covered in this lesson. The first one is Amazon FSx for Windows File Server, which is a fully managed, highly reliable, and scalable Windows native shared file system built on Windows File Server. So this is meant for Windows instances. So the way you do it is that you deploy the FSx, usually across two availability zones, and then there is support for all the Windows native protocols, such as the SMB protocol and Windows NTFS, which allows you to mount this file system onto your Windows machines. And so if you look at your corporate data center and you have a Windows client, for example, over SMB, it's able to access the Windows file server. But also if you had EC2 instances that are Windows-based, then they could also might as well access this Windows file server. So Amazon FSx is the way to deploy this Windows file server that leverages the SMB protocol and Windows NTFS. Because this is also a Microsoft type of offering, there is integration with Microsoft Active Directory for user security, and Windows file server in Amazon FSx can be accessed from AWS directly, or as you can see on this diagram, from your on-premises infrastructure. Now, the second flavor of Amazon FSx you have in AWS is called Amazon FSx for Lustre. And you need to remember that this is to have a fully managed, high performance and scalable file storage for high performance computing. So whenever you see storage for HPC, so high performance computing, think FSx for Lustre. Why? Well, Lustre is derived from the name Linux and cluster. So put together, it's Lustre. And so imagine cluster like processing this kind of things. Maybe it's a way for you to remember what Amazon FSx for Lustre is. This allows you to run a lot of use cases for high performance computing, such as machine learning, analytics, video processing, financial modeling, and it scales to extremely high traffics in terms of hundreds of gigabytes per second of data exchanged, millions of IO operations per second, sub-milliseconds latency, so it's really a high-performance file system. So the way it works is that Amazon FSx for Lustre can be connected either to your corporate data center or to your compute instances directly within AWS, and then in the backend, Amazon FSx for Lustre is actually storing your data, possibly onto an Amazon S3 bucket. So that's it. That's all you need to know for Amazon FSx. There's no easy hands-on to do it, so I will skip that. But just remember the two flavors of Amazon FSx going into the exam, and you should be good to go. So that's it. I will see you in the next lecture. So let's summarize what we have learned in this section. The first one are around EBS volumes. They are network drives that are attached to one EC2 instance at a time. They're mapped to a specific availability zone, and we can use the EBS snapshot feature to do backups or to be able to transfer the data from one EBS volume across to another availability zone. We've seen about AMIs. They're ready to use EC2 instances images with the customizations we want. And if we want to automate the process of building an AMI, we can use the EC2 image builder service to automatically build, test, and distribute AMIs. We've seen EC2 Instance Store, which is a way for us to have a very high performance hardware disk this time attached to our EC2 instance, but it is lost in case our instance is stopped or terminated. If we wanted to have a network file system, we would use the EFS service. With the EFS service, we can get an NFS that we can attach to hundreds of instances within a region. So there's no AZ lock. Now it's at the region level. And if we want to cost optimize our EFS service, we could use EFS IA, which allows us to move the files that are infrequently used into a lower cost tier. Finally, we've seen about FSX. FSX for Windows, which is a way for us to get a network file system for Windows servers, and FSX for Lustre, which is for us to perform high performance computing, so HPC, on a Linux file system. So that's it for this section. I hope you liked it, and I will see you in the next section. So let's do a quick cleanup just to make sure we have a clean slate and that we don't overpay anything, even though we are in the free tier. So if you go to the EC2 dashboard, you will see all the resources running in your region. So I have 2 running instances. I'm going to open this in a new tab, 4 volumes, and then for key pairs, you can leave it as is. It doesn't cost you any money, no matter what. Snapshots, I have 2, so I will open this in a new tab. And then finally, security group as well. They don't cost you any money, so I'm going to leave them as is. So for our EC2 instances, you can take them all, right-click, and then terminate them. This is very easy. This is the cloud. Then for the volumes, we have some root EBS volumes that are going to be deleted as we terminate our instances. But for these 2 EBS volumes, I'm going to delete them as well manually. Okay. And finally, for the snapshots, I can delete the snapshot right away. So I can take these 2 things, do action, delete the snapshot. Yes. And then it says this one is not being able to be deleted because it is being used by an AMI. So I will say, okay, go to AMI on the left-hand side. I'm going to delete my demo AMI so I can just deregister it. I say, yes, I want to be deregistering this AMI. And back into our snapshots. Now I'm able to get this one, delete it, and say yes. And now we should be good to go. So if I look at instances, all terminated. If I look at EBS volumes, none of them, and snapshots empty and AMI empty. Okay, that's it for the cleanup. I'm going to refresh this, and as we can see, we are good to go. And I will see you in the next lecture.